Salam all. Today we are going to learn about the arithmetic syntax, which are the add operation, subtraction operation, multiplications, and division. Okay, so that is part of the arithmetic that we're going to learn for this lecture. So let's look at the first one, the add operation. So the definition is to add the source operand, okay, the source operand to the destination operand using the binary addition and store the results in destination location. So what happened is, in this particular add is very simple. This destination will add the source operation and the result will be saved back to the destination. Same goes to this one. For example, this is a data register and this is your source effective address. So for the other one, for example, that we have the destination is not the data register, which is the effective address, possibly the memory, then you can see that you are going to add the contents from the destination effective address with the with the data register, and the result will be saved back to this destination effective address. Okay, so the operand must be one of the operand must be a data register, must be, so it is a must. You must have any of it, must be, or you can be both the end to the end, doesn't matter, as long as one of them, it should be a data register. The size can be byte, word, or long word, and this one I'm not going to touch it for the machine format code. Okay, let's look at the example here. Example say, given D1 this number, D2 this number, and the locations given at 2000, the contents is AABBCCDD. This one should be $sign. Alright, so I'm going to save this one. Okay. Okay, now looks at the first command, add.byte D1 and D2. D1 is given this one, D1 is given here, and D2 is given here. The byte size will be this one, and the byte size over here will be here over this one. So for this case, the destination is going to be add to the source and going to replace back at the destination. So 77 plus 44 in hexa. So you can try here, mode 3. Okay, in hexa, 77 plus 44 is equivalent to BB. So the answer now is going to be inserted at D2. Okay, very simple. Now let's move to add.w hash. Hash $sign means is a constant number. You must add to D1 and save back to D1. So over here, you are going to save a word size. Add first D1. D1 is given 5544. So 5544 is a word size. So over here 5544 plus 3400 equivalent to 5544 plus 3400 is equivalent to 8944, and the result is saved to the D1 for the word size over here. So this is 8944. Okay, the last one is add.long. D1 $sign only means you are referring to the locations, and this location is given the value is AABBCCDD. So long word means it should be 32-bit. So the whole number here should be a long word. It's going to be add to D1, and then you're going to save back to this location. So let's try to have a calculation on the calculator. Hex AABBCCDD plus D1 11225544, and the answer is BBDE 2221. So you're going to have this value all this value go back to the location at 2000, and you have to replace the memory. The location value is BBDE2221. This is the initial value AABBCCDD. So it's the same. Okay. So let's try to so it's not the same. It's just I mean that so this is the initial value and the latest one is over here. So what I mean the same is actually is the add operation is quite simple. You just add the values and then you have to put it back somewhere. And let's just try once at the easy 68K. I just want to do very fast this one, since you guys should know already how to do it. So let's try to do the first one. I want to delete this one. I'll just do once only. Okay, so move that long hash $11225544 to D1, and then D2, move that long hash $44556677 to D2, and then the command is going to be add.py D1 D2. So D2 and D1 will be add and will be reserved and will be saved back to D2. Let's run this one. So run by line by line. So move to this number to D1, then you have this to D1 D2, then you're going to add the byte size D1 D2. So the final will be saved at D2. Look at the answer over here. Then you have the latest one is 445566BB. So it's the same thing in these slides. Okay, let's move on. Next one, add address. So the difference is here versus the add over here. You have A over there. So what does it mean? You have to add, and the final destination should be this one, address register. Just now you are using data register, right? So now the final destination must be an address register. The operation is the same. Add the source operand to the destination, source plus destination, and stores back to the location here for the AN. This is the last location that is going to be saved. And the important thing is it only can use word and long word size. Just now you can use all size byte, word and long word, but for this case you only allowed to use word and long word size because of this A operation, add address. And then the next rules is the entire of address register, this guy, must be used regardless of the whatever operation in the size, which means that whatever contents inside AN must be add at this guy and be saved back to AN. So let's try to look at the example here. Given A1 is this guy, okay, A2 is this guy, A3 is this guy, and D4 this guy. So add address.w D4 A1. So remember that you have to take all A1 contents. A1 must be all here, 66778899. Must be at word size from D4. D4 is this one, so the word size must be 1100. So let's try to add this number. A1 is given by 66778899 plus D4 1100, and the answer is 66779999. Okay, it's the same thing. It's the same one, the same answer that I have. And then you are using the same another example here at address dot long. This is hash $, a number plus A3. A3 is what? This one. So 1199CC DD. Okay, and you're going to add with the value 77 and the answer is 1199CD54. And the last one is at address W. This is a location you have to take from this location in word size, and then you have to add the address register and save it over here. So 8002 is given this value, 8000 is this value, so I have to put the dollar sign, so just to make sure that the number should be correct. So the word size, the word size, you can see that at 8002. So this is 8001. 8000, sorry, this is 8000. This is 8001, and 2 starts from here. The word size must be this guy, 2233. Now you have to add A2. A2 is given 55332211 plus 2233. Then the answer is 55334444. Okay, I got the same answer. You can try it by using your Easy68K to check the value. Then we have the add quick. So what is this? Just now we have the add A, and add quick. So what happened is in add quick, you only allowed to have the value from 1 to 8 only to add quick. Okay, so that's the case. Other than that, you cannot use add quick. 10 you cannot use, only 1 to 8. The format is add quick.size. It can be a data over here to the effective address. The data must be from 1 to 8 only, so that is the value. The data must be this one. Okay, the size for this case is byte, word, or long word can be done. If address register is used, okay, if address register, the permitted size is only word and long word. So if you want to use address register at the back, which is maybe, for example, the effective value can be an address register, again you only can use word and long words. Byte is not allowed. So when adding to the address register, the condition codes are not altered, and the entire destination address register is used regardless of the operation size. So the whole destination address is used. If you use word or long word, you are going to use the whole thing just now. Like for example, the address just now, you're going to take the whole thing. Okay, except that the data here you must use the size over here, but the address you must use everything. But for data register, you must use the same size that you allocate over here. Must here. Okay, let's move on. Add quick example. So add quick.byte number 6 to D1. Okay, D1 is given this one, and you're going to add 6. You remember that only 1 to 6 only, 1 to 8 only. So D1 is given this number, so you just add 6. 0, 1, 2, 3, 4, 5, 6, 7 plus 6 in hexa. The answer is going to be 0. This is 0, 1, 2, 3, 4, 5, 6D. Correct. This one, $1, is the same thing. If you use without $, or just number 1 is equivalent for the hexa and decimal to A2. Then you can see that A2 you plus 1. A2 is given as this number EFFFF. E F F F F F F 1 2 3 4 5 6 7 8. Another F, and then you have to plus 1. The answer is going to be F0000. It's the same answer that I can get from my calculator. Same go to the last one. This is a number. A number percent means that constant percent. This is in binary numbers. So binary numbers, let's go to binary numbers. 101 is equivalent to what? In hexa is going to 5. So you're going to add the location here at long word size at 7000. Then you have to add 5, and then you have to put it back. So add.quick.long will be having all this number. This is the location 7000, and the contents is this guy. So AA, BB, CC, DD plus 5. and the answer is AABBCCE2. You have to put back at this location. So each of the memory will get only 8 bits of size, which is AA, BB, CC, and E2. Okay, that's for add quick. Let's move on. Add immediate. Nearly the same like add quick, but the thing is you can add immediate any data. The numbers is not allowed only 1 to 8. You can do that more than that. So if you look at the command, it's the same thing. Add.immediate.byte. This is a value, and you're going to add and store to D1. So D1 is given this one. I can just try this one. 0, 1, 2, 3, 4, 5, 6, 7 plus 11. And you can see that the result is 1, 2, 3, 4, 5, 6, 7, 8. It's the same answer given in my calculator. So you can try all this one again because this is all the similar example. Okay, let's move on to subtraction. So subtraction means this is a bit different. Operation subtracts the source operand from the destination operand and stores the result in destination, which means that you are going to have your destination minus your source, and will be saved to your final result, which is data register. This is data register. Same goes like just now for the add. You can see that this is the operation. The final destination, which is the destination over here, minus effective rate for the search, is going to be saved back to the data register. So this is related to this one, and this one is related to this one. Okay, let's move on to the questions answer example. Here is going to be sub.byte D1 D2, so means D2 going to be minus from D1 in byte size. So D2 going to be minus from D1. D2 is given as 4, 4, 5, 5, 6, 6, 7, 7, but only for the byte size should be 7, 7 over here. So 7, 7 minus here D1 is 44. 7, 7 minus 44, and then you have to restore back to D2. Okay, the D2 consists of this one, so the changes will be at the byte size 33. This is the answer. Okay, so this is the answer. Okay, minus. Next one is again you have to minus D1 from this value. This is hash $3400 D1. D1 is given this one. Word size will be 5544. 5544 minus 3400, and then the result is 2144. You can see that the result is over here. Same goes to this one. This is I keep on repeating this. This is that $sign only means that you are referring to the memory location. So you can try look at the value over here. This one also should be $sign. Save this one, and then from here you can just subtract the contents from 2000 in long word size. Long word means you have to take everything from 2000, AA, BB, CC, DD, and then you have to minus D1, the location at the data register 1122235544. Let's try to minus out that one, AA, BB, CC, DD minus 11225544, and the answer is 99997799. Remember that each of the memory, the size is only 8-bit. That's why you only have 2 digits for the hexa over here. Okay, let's move on. So for sub address, again, this is another one, just like the address for the ADDA just now. Operation subtract the source operand from the destination address register and stores the result in the address register. Again, you're going to have your destination address register here minus the source operand and save back to the final destination over here at address register. So because of sub A, destination must be an address register. Size now is only word or long word, and word size source operand. Okay, source operand here are sign extended to 32-bit quantities prior to the subtraction. So it means that if you use W, you have to do sign extend rules. And then you can minus from the this one, you can minus the the contents in the word size after you sign extend it. Okay, so let's try to look at the example. Okay, the first one is sub address. Okay, sub address.w. W, you must know that you're going to sign extend it. So A1 is given this value 66778899, and D4 is given this one 33228800. So the contents here for D4 for word size is 8800. But you need to have this value to be signed extend. So 8, the MSB is 1, so you're going to have all FF8800. So A1 minus that value. So A1, what is it right now? A1 is 66778899 minus the value for the extend is going to be FF, okay, 8800. So the answer is 66780099. Same thing. Okay, then you can go to sub address long. Long means that you are not going to do the sign extend. So just take this value, add to this particular, the whole A3 address register. So this is going to be 1199 CC and DD. Okay, so plus 77. Okay, so that's the answer, 1199 CD. Sorry, what is it? Is it plus 77? Sorry, let's try again. Sub address.long A3 is given this one, 1199 CC DD minus, should be minus 77. Okay, the answer is 1199 CC 66. Okay, I got the right answer. So sub address W, the contents are this location W is 8002. 8002 is starting from this value. Starting at this value. Sorry, this value. So the MSB is for the 2, MSB is 0, so the final sign extend will be 0002233. Okay, let's look at the answer. A2 is what? 55332211 minus the contents of the 8002, 2233, because there's no FF over here, so we should just use 2233 because 0 is nothing over there. So the answer is 55, 32, FF and DE. So that's the answer. Okay, then you have the SUBQ. Again, the SUBQ is related to, again, 1 to 8. And then you can see that the data here must be subtracted from this one. Okay, from the destination. So the last the effective area for the destination, not source over here. Okay, if the destination is this is again, if you are going to have this one as address register, that's the problem. Every time you work with address register, see this one, the entire destination address register is used regardless of any operation size. If you use byte, word or long word, you have to use all the contents in the address register if you are using the address register for the SUBQ. So you can look at the example over here, very quick one, SUBQ. And then you have the SUBQ D1 minus 6. So D1 SUBQ B, D1 is given this one, so 67 minus 6. So the answer is 61. So that's the answer. Okay, now look at the second one, SUBQ W A2. Okay, 3, because this is word size. Remember that word size, you have to use all of the contents in the register. A2 is given all this one. So 22223333 minus 3. So the answer is 22223330. And the last answer, the last example is related to SUBQ.long. This is hash percent sign. This is 101 in binary, and the answer is 5. So SUBQ.long 7000 location. You have to go to this 7000 location and get the long word. This is the whole long word, AABBCCDD. BBCCDD minus 5. Then you can get the answer AABB, CC, and D8. Okay, that's for SUBQ. And then you have the sub-immediate. Same again, sub-immediate, you can use more than 8 numbers. So again, you have just minus the effective address for the final destination from the effective address from the source over here. This is your data. Sub-immediate must have a data over here. And you can see that this is all data, and you can do the same example just now. This is minus D1 minus 11 in byte size, 67 minus 11, 67 minus 11. You got 56 over here, correct? So sub I.W 2222, this is bracket A2, means that you have to refer to the memory. This is, yeah, I just can say that if you want to look at this one, A2 is given this one. So you can see it's equivalent to if I put that $ directly to 0005000. So if I don't have this one, it's the same thing. If I just put this value over here and I'm referring to the locations, okay? But in this example, you just use the bracket A2 at 5000, words at 5000. Okay, what's the value here? So the location 5000, this is the location and the contents. So the word size would be this one at starting from 5000, 33AA, word size 33AA. Okay, 33AA minus 2222. 33AA minus 2222. So it should be 1188. So that's the answer. Okay, you can try the rest. I think it should be quite easy for the add and subtraction. So let's move on. Okay, I'm going to move directly to the multiplication. Okay, multiplication. So here in your multiplication, you're going to multiply a numbers. So what happened in this particular syntax is it will multiply two unsigned operand yielding an unsigned result. So before that, I'm going to clear up what is the meaning of unsigned and signed. So we are going to learn about unsigned and signed. Okay, just very simple. For unsigned will be all positive number. So no matter what number it is, it all belongs to the positive number. So here in unsigned multiply, you're going to multiply a positive number with a positive number, which resulted in a positive number. This is your form 4, form 5, I think, mathematics. And then you can just look at the sign value over here. This sign means that the value can be either plus or negative value. Okay, so the sign will be the next chapter, the next slide. So we are going to look at the first one, MULU, which is the unsigned multiply. Okay, unsigned multiply. So what does it mean now? It will multiply two unsigned operand, which is a positive and positive number, yielding an unsigned result. Of course, positive times positive, result will be positive. Very simple, this one. And the multiplier and multiplicants are masked word operands. Okay, and the result is a long word operand. So what does it mean here? You must use W times W. The answer must be a long word. Okay. Okay, a register operand is the lower word order. The upper word of the register is not. So this is related to the register operand low order word, the last 4 over there, and the upper one is ignored. So you don't care the top 4 numbers in the registers. Okay, let's try to look at the example here. So multiply unsigned 3 to D1 and save to D1. Okay, D1 is given this value. So now you have to use word size. Word size, remember that this word size is used, this one don't care. This word size going to multiply by 3. 3 in hexa, same goes to 3 in decimal, and you just multiply it. Okay, 00A0 multiplied by 3, you're going to receive 01E0. So you're going to receive this value, and then it should be long word size, right? Remember that? So you have to put all 0 at the front over here for the whole D1 registers. Okay, next one, D2 times D3. D2 times D3. So D2 is given as this one, FF00, and then D1 is given 00A0. So let's try D3, D3 is given 003. Now you are going to just multiply this one, FF00 times 3, right? 003. And the answer is 2FD00. And because of it should be a long word size, so you have to add all 0 at the front up to the 32-bit. Okay, same goes to this one, multiple unsigned. The contents at D2 must have the word size. Word size for D2 is FF00 times MULU word size 2 as 7002. 7002 is given this one. This is 7000, 7001. 2 is coming here, B000. And then you are going to run it. Okay, let's try to run it. Let's try to calculate by using the calculator. D2 is given FF00 times 7000 is B000. B123. And the answer is AF500000. This is all the whole contents of the registers. Okay, multiply unsigned should very easy. Okay, now you are going to learn about multiply sign. So what does it mean? Multiply two sign operand yielding a sign result. Same thing just now, but the thing is now you have to prepare for the sign. You must know that this is a negative sign, this is a positive sign. If you multiply this one, it's going to be negative number. Okay, this is the one that we learned before. Plus times plus, plus, minus times minus, plus, plus times minus, negative. So minus. This is the same thing, minus times plus is going to be negative also. Okay, so multiplier and multiplicand are both word operands, same again like word operands, and the result is also long word operand. So it should be word times word is equivalent to long word. Okay, but the thing now, you must know that you must represent the numbers in a second complement form. If you go back to your last, I think you're in your first year. So second complement is a number representation of a negative number. Okay, so you must know how you want to click your calculator to show that that is a negative number. Okay, the comma must be multiple sign, the effective address and data register, and will be saved back over here. So let's look at the example now. Okay, multiply sign number 3. 3 is a positive number. D1 you have to go to the word size, the last 4 digit. D1 is this one. So how to know that this is a number, positive or negative number? You have to look at the MSB value over here. If the MSB is equivalent to 0, that will be going to be a positive number. Okay, so in this case is 003 times 0080 is a positive number times positive number, which resulted in positive number. So you can see 0002, let's try 0003 times 0080, the result is going to be 000001E0. Okay, because of you have to complete the whole long word, right? So you have to put all 0 at the front here. Here you have to put all the front here, because this is nothing at the front, so here you have to put all 0 to make sure it's a long word size. Now let's look at the second example, multiply sign D3 D2. Okay, let's look at the example D3. D3 now is going to be D3 here, Okay, the last 4 digits 0003, this is a positive number. And then you are going to look at D2. D2 is where? Let's look at the D2. D2 now is FF00. When you see that the MSB is 1, this is a negative number. Okay, negative number. So you can try now. Let's try whether you can get the answer or not. Okay, you can try, just look at, by using the same calculator, FF00 times 3. This is not the same answer. Okay, this is not the same answer. Why? Because in calculator, you must represent it in negative number, then you can do demultiplication. So how to represent a number in your calculator? Okay, I'm showing you a very simple representation of -1 in decimal and then go to hexa. So we go to decimal over here. Let's try. So 0 minus 1 is equivalent to -1. So this is decimal number for -1. So how the second complement represent this number? If you go to the hexa number here, it will be all F in 8 digits. Okay, if you have a number with MSB, the MSB here is 1, it can be a negative number. So let's try, put 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Let's try, so it's a negative number. As long as MSB is 1 over here, it will be a negative number. But if you put only 7F, right now you put 7F, 1, 2, 3, 4, 5, 6, 7, and you have to imagine that the MSB here is 0. If you convert this one, 7, right? No, this one, hex. 1, 2, 3, 4, 5, 6, 7. So the MSB is 0. Then if you convert to decimal, it's going to be a positive value. So if you put F for 8 digits, then it's going to be putting a negative number. So remember that. So -1 in decimal is equivalent to FF for 8 digits. Because of this, MSB is equivalent to 1, so the system say that this is a negative number. That is your calculator saying. So if you put only 7 digits only, means that the MSB will be 0. Then if it is 1 only, then it's going to be a positive number. If 7 plus 0 over here, then you're going to have a positive number. You can try to look at the location in the calculator how to do the conversion. So what happened here in this example, right? So D3, D2. D2 is given this FF00. FF00 is a negative number, so you have to put a representation as the whole upper part should be all F. So now FF00 times D3. D3 is given by 3, and the result is, sorry, this is should be hexa. So FF00 times 3. You can get the answer is FFFFD00. So that is the answer. So let's look at the last example here. Okay, this one is the location here is going to be multiplied by this one, saved to this one. So D2 is given by D2 FF00. So this is a negative number because of this MULS sign. So this must be represented as negative number. So then 7002. 7002 is what? 7002 is B000. So this is also a negative number, so you have to represent all B000 as a negative number because this is word size. So now B000 times D2, right? D2 is FF. So all F at the front, 1, 2, 3, 4, FF00, and negative times negative, you must receive this one as a positive number. So it's a 500,000. So at the front is going to be 00. So this is correct. Okay, that is the difference between MULS sign and multiply unsigned. So multiply unsigned is very simple. Just make sure that you don't put until up to 8 digits over here. When you put digits over here, your MSB is 1, then the calculator now is telling you that you are putting a negative number in second complement. Okay, that's for the MULS sign. Okay, let's move on. Now for the unsigned division, divide. Okay, div unsigned. Okay, what happened now in div unsigned is, okay, it will divide the unsigned operation, operand L, by the unsigned word size, and it will store the unsigned result in the destination with this one 16R and 16Q. This is 4 bit. This is 4 digit. This is 4 digit. This is related to the what I call this one? I forgot this one. R. This is the remainder, something remainder. We are going to look at the example here later. I forgot to look at what's the meaning of R. Okay, what does it mean over here? You have a long word size. You're going to have the division by here word size, and then the result must be word from here and the balance from here. Okay, you can see that this is the result. Okay, multiply is different. So right now it's long word, divide by word, and you can get the first answer from here, and the second answer must be from the remainder. Okay, let's look at the example here. Okay, before that, let's look at the mathematics, simple mathematics before. Let's just use a decimal number. Okay, 5 divided by 2. So this is what you learn in your primary school. 2 times 2 is equivalent to 4, and your remainder will be 1. So this is the first answer, and this is your second answer. So same goes to the hexa numbers. So in your calculator, right, you just use directly the base mode here. Let's say for example this one, you want to know the value for let's say try to do this one. Okay, I just put a number. Okay, 197 divided by 3. This is decimal number. Let's try to put a decimal number. So we play with decimal number first. Don't go for the normal one, because in normal one then you have the points over there. Here you will not receive the points. So go for decimal. 197 divided by 3. You can get this answer 65 here. Remember that? This is 65. Then what you do is you are going to 65 times 3. Okay, 65 times 3 is what? 65 times 3 equivalent to, 65 times 3 is equivalent to 195. And your balance will be 195, and your balance will be 2. Okay, so this is how you can do a shortcut in your calculator. Okay, so in our 68K, we are using hexa numbers, so we can use the same method, the same process in the hexa mode. Okay, let's try to look at this value. So this is quotient, this is remainder. Sorry, this is quotient. Quotient is this one just now. Oh, now I know this one. The meaning of this one is, this is quotient and this is remainder. R for remainder and Q is for quotient. Okay, now is a D2 divided by D1. D2 divided by D1. So long word going to be divided by D1. D2 is this whole long word 3 divided by D1. D1 is given by 2. So what you can do now is you just change to the hexa mode. Hexa here. So 3. Okay, let's put this one first. Three divided by 2. In hexa numbers, 3 divided by 2. You can get what's the answer is 1 base 16. And then you are going to multiply this value. 2 times 1 is equivalent to 2. And you're going to minus out this one, and the balance will be 1 in 16 base. So you can get the first answer. The first one is 0, 0, 0, 1. And the second answer is going to be 0, 0, 0, 1. This is your remainder. This is your quotient. So how to put that value? The first one should be what just now? The first one should be remainder, and the second one should be quotient. So now the first 001 is remainder and the second one is a quotient. Because of this coincidentally is the same numbers, we can put this value here and there. Alright, let's move on. D3 divided by 5. D3 divided by 5. D3 is given this whole long word 000122232. So let's look at the calculator again. Okay, 000122232 divide by 5. So just use this one again. Okay. One, two, two, three, two. Correct. 0, 0, 0, 1, 2, 2, 3, 2. Okay. Divide by 5. 5 value over here. Divide by 5. Okay, divide by 5 over here. So this is base 16 too. So let's just use your calculator. Okay. I don't care about the first few values over here because 0, 1, 2, 2, 3, 2 divide by 5 in hexa mode. Then you can get the answer is 3A, 0A. And you can know that by multiply this value, you can get the answer below here, and then you can find the the remainder for it. So now this is the answer 3A, 0A times 5. Sorry, result answer times 5. So the same number 0, 0, 0, 1, 2, 2, 3, 2. So there's no balance, so all will be 0 here. So the answer must be remainder quotient, right? So remainder is 3A, 0A, and the last answer will be 0, 0, 0, 0. Is it the same one? Or remainder first? Sorry, remainder is not. Remainder first, sorry. This is remainder, and then you get there 3A, 0A. Alright. Okay, this is division. So you can try this one. Okay, you have the calculator over here. Try to get this value, and you can get the quotient and remainder. Okay, for this one. Okay, let's move on to the sign divide. Now, the thing is, you are going to use the same thing as the multiply for the sign numbers. Division is the same one like this one, division, but this one is only for the positive value only. So this one is going to be a negative value accordingly to the MSB for the numbers. So again, this is going to be in second complement form. So let's look at the example here. So divide sign D1, D2. D2 is going to be divided by D1. Okay, D2 is what? This is the value for D2. Word size should be FFFD. FFFD means you're going to take this value only, but the thing is now the MSB is equivalent to 1 and this is signed numbers. You have to look at the MSB over here. So it means that you have to put the value for this value is going to be FFFD, okay, divide by the value at D1. D1 is a positive number. This is word size. Word size is the MSB is 0. It's a positive number. Divide by 2. Then you can get the answer FFFFFFFF. But because you only have to put words only for the quotient, this is the quotient for the FF. This is the FF value going to put at the quotient over here. And then you have to find the remainder. Okay, let's try to do it again over here. A FFFD. So this is going to be FFFFFFD divided by a positive number, which is 2. Right? This is 2. This is division sign. You have to look at this value. You have to look at this MSB value. This is of course a negative. Just now it's FFD, right? So you're going to put all F over here because to represent a negative value. Okay. So now look at the answer here. FFFFD divided by 2 is equivalent to this value, all F. 1, 2, 3, 4, 5, 6, 7, 8. So you need to take only the last 4 over here as the quotient. And now this value multiplied by this value, you can get what answer? To get the remainder. So this value going to minus times 2. So the answer times 2. You can get the value is FE. So you minus out this one. Okay. FFFD minus the answer this one. Then you can get the result is all also FF. The result is all also FF. And coincidentally that the last 4 is the remainder. So the answer will be going to be FFFF for the quotient. Okay, so the rest is the same. For this number, this is a positive number, and D3 is a negative number, E789. This is a negative number. So you can try by using your calculator to get this value. Again, by using my concept, my method, you can get this quotient and remainder. Okay, same goes to this one. You have to try to understand the concept and look back the example that I showed you just now on how to use your calculator in terms of negative number to try to do the multiplication division, and you can get the remainder over here. Okay, this is the value. If you cannot get the answer, you just put the comments and then tell me what is the problem. Okay, so that is for today's lecture. We had covered the add, subtraction, multiplications, and division. And the most important thing about you have to understand about the division and multiplication on the unsigned versus the signed numbers. Okay, that's all. Try your best in your assessment, your quiz, or all the best. Thank you.